Main focus of the task in this training is as follows. First, in order to reduce errors in data, it is recommended to examine the problem with several trials, instead of finishing it with a single trial. Second, testers such as digital thermometer must be measured on the same spot for both normal operation and fault finding. Third, when measuring the air velocity, it is necessary to measure the air velocity in several different places instead of measuring it in one place and then calculate the average value. Fourth, when installing and removing a manifold gauge, make sure to minimize the release of refrigerant in the hose into the atmosphere. Fifth, after the repair is complete, make sure to check if the machine operates properly. Sixth, to figure out the reason for the fault, the workers need to be trained by comparing the normal refrigeration cycle and the refrigeration cycle which has a mechanical fault. Please check the preparations and tools for this training. These are precautions. First, before repairing the fault, competitors should attach a danger sign at the end of the power cord. Second, since the work deals with the refrigerant, make sure to wear a safety gear to prevent low temperature burns. Third, temperature measuring sensors should be attached to the correct location. Fourth, measuring equipment such as thermometers and manifold gauges should be adjusted to zero accurately before use. Fifth, when supplying power, make sure to wear insulated gloves. Sixth, do not forget to perform short and insulation tests before powering on. Seventh, the cause of failure is the decreased low pressure, so be cautious of changes in low pressure. Eighth, be cautious that additional damage to equipment such as compressors may occur when malfunctioning equipment is operated for a long time to find faults. Ninth, to prevent external influences on the measured temperature values, the sensor must be kept warm before measuring. Please check what you are going to perform on this task. Connecting the gauge for diagnosing faults. In order to identify the mechanical fault in the machine, disassemble the cover and install the required equipment such as temperature sensors, clamp meters, and manifold gauges. Install a thermometer to measure temperature. In order to reduce errors in measurement, use a digital thermometer which has a contact-type temperature sensor. The disassembled cover should be temporarily assembled again for the safety. The thermometer should be installed on the same place in both normal and damaged machine. The sensing parts should be insulated so that the temperature does not change by external factors. The thermometers is installed at each outlet of evaporator and condenser based on cooling operation. Connect the sensor to the thermometer body to check if it accurately shows the current temperature. To check the operational current of the machine, install a clamp meter. Connect the manifold gauge. Connect the blue low-pressure hose to the service valve. After installing a removable valve core, connect the red high-pressure hose to the high-pressure part. Inspect gauges and connecting parts thoroughly with a gas detector to check if there is any gas leakage on the hose-connected parts of the installed manifold gauge. Diagnosing normal operation conditions. Write the data of normally operating equipment. Measure and write down the compressor operating current. the air velocity of indoor and outdoor unit, the high and low operating pressure, the superheat, and the subcooling. When measuring the air velocity of indoor or outdoor unit, divide the inlet and outlet of the indoor and outdoor units into 4 to 6 sections, and measure the air velocity in each divided sections to calculate an averaged value. This is a malfunction of the evaporator air volume reduction. Intentionally create the malfunction state in which the air volume of evaporator is decreased by adding the paper over the indoor unit. Check how the data gets changed compared to the data from the normal machine. Measure and write down the compressor operating current, the air velocity of indoor and outdoor unit, the temperature of evaporator outlet, the temperature of condenser outlet, the high and low operating pressure, the superheat, and the subcooling. If the air volume through the evaporator is abnormally insufficient, the refrigerant flowing in the coil will not evaporate properly. The refrigeration capacity is lower than when the refrigerant evaporates normally, and the refrigerant that is not evaporated is inhaled to the compressor side, which causes failure. There are many reasons that reduces the air volume of evaporator. First, there is a case where the air filter or evaporator on the suction side of the indoor unit has foreign substances or dust, decreasing the air volume. In addition, there is a case where the evaporator is not operating in normal RPM because of the broken motor. There is a case where the wing of fan is broken. And there is a case where objects interfere with the airflow in the inlet and outlet of the indoor unit. Therefore, when the evaporator is experiencing the decreased air volume, make sure to measure the air volume. Let's compare the data of when the evaporator is experiencing the decreased air volume with when the machine is operating normally. Let's check for any noticeable changes. Decrease in suction pressure. Decrease in superheat of evaporator. Decrease in air volume of evaporator. Decrease in subcooling of condensers. Decrease in operating current. The reason for the data change is because the heat exchange is not taking place properly at the indoor unit. Therefore, make sure to conduct overhauls and maintenance on the machine thoroughly to prevent the blockage in air filter and the contamination in refrigerant pipe and cooling fin of the evaporator, and to make evaporator fans operate properly. When there occur the symptoms such as the decrease in suction pressure, the decrease in superheat of evaporator, and the decrease in air volume of evaporator, the faulty heat exchange of the evaporator is assumed to be the reason for the fault. This is a malfunction due to insufficient refrigerant. Reclaim the refrigerant from the refrigeration system intentionally to make it in a dysfunctional state. The reclaimed amount of refrigerant is 200 grams out of the fixed amount of 1,000 grams. Check how the data gets changed compared to the data from the normal operation. Measure the compressor operating current, the temperature of evaporator outlet, the temperature of condenser outlet, the high and low operating pressure. Insufficient refrigerant may result in a decrease in both suction and discharge pressure. In addition, the increasing superheating degree of the system causes compressor failure due to overheating and deterioration of the freezing capacity. Measure and record the air velocity of the indoor and outdoor units. When measuring air velocity, the air inlet or outlet of the indoor and outdoor units shall be divided into 4 to 6 equal parts to measure the air velocity of each zone and obtain the average value. Let's compare the actual value of when there is a lack of refrigerant with when the machine operates normally. Check for any noticeable changes. The reclaimed amount of refrigerant is 200 grams. Decrease in discharge pressure. Decrease in subcooling of condenser. Decrease in suction pressure. Increase in superheat of evaporator. decrease in compressor operating current. When there is a lack of refrigerant of refrigeration equipment as well as measured data. If a sight glass is installed, bubbles are visible in the liquid refrigerant. Therefore, when there occurs the symptoms such as the decrease in discharge pressure, the decrease in subcooling of condenser, the decrease in suction pressure, the increase in superheat of evaporator, and the decrease in compressor operating current, the lack of refrigerant is estimated to be a reason for the fault. This is the situation where the pipe is dented. Distort the pipe of the refrigeration equipment intentionally to make it in an abnormal dysfunctional state where the refrigerant flow is hindered. Check how the data gets changed compared to the data from the normal machine. Measure discharge pressure and suction pressure during operation. If the refrigeration circulation is hindered, only a small portion of the refrigerant goes through the evaporator, resulting in lower suction pressure. Measure the temperature of evaporator outlet and the temperature of condenser outlet. When the filter dryer in the liquid tube is blocked, the outlet temperature is lower than the inlet temperature due to the difference in pressure between the inlet and outlet of the filter dryer. Similar problems occur when the liquid line is blocked or bent. Measure the compressor operating current. If the refrigerant does not flow smoothly, the pressure at the low pressure part gets low. It causes the low pressure controller to operate, which stops the refrigeration equipment. Measure and write down the air velocity of indoor and outdoor unit. When measuring the air velocity, divide the air conditioning unit into 4 to 6 sections to measure each section and calculate the average value. Let's compare the data of when the pipe is dented with when the machine operates normally. Check for any noticeable changes. Little decrease in discharge pressure. Little increase in subcooling of condenser. Decrease in suction pressure. Increase in superheat of evaporator. The reason for the data change is because the refrigerant circulation is hindered. Only a small portion of the refrigerant circulates, resulting in lower suction pressure. The superheating changes as the evaporation process becomes shorter and the suction pressure decreases. Therefore, when there occur the problems such as little decrease in discharge pressure, little increase in subcooling of condenser, the decrease in suction pressure, and the increase in superheat of evaporator, the dented pipe is estimated to be a reason for the fault. After completing the task, the tools and measuring gauges used for examining and repairing the fault should be removed. All sorts of covers or caps that were disassembled, such as a pressure controller and joint box, should be reassembled to the original state. We have reviewed 3 causes of failure operated under low suction pressure up to now. The reasons why the suction pressure in refrigeration unit gets lower comes from the failures of piping such as decreased air volume in evaporator, a lack of refrigerant, the dented pipe. In addition, there may be several causes such as valve lock, expansion valve lock, or failure. These are differences in the measured data depending on 3 reasons above. When the decrease in air volume of condenser is the reason, the symptoms such as decrease in suction pressure, decrease in superheat of evaporator, and decrease in air volume of evaporator may appear. When the lack of refrigerant is the cause, the symptoms such as decrease in discharge pressure and increase in discharge gas temperature, decrease in subcooling of condenser, decrease in suction pressure, increase in superheat of evaporator, and decrease in compressor operating current may appear. When the defective piping system, such as a dented pipe, is the cause, the symptoms such as little decrease in discharge pressure and little increase in subcooling due to the changes in the condenser pressure, decrease in suction pressure, and increase in superheat of evaporator may appear. Even if the suction pressure is low, there can be a difference in the specific data depending on the situation. In order to quickly find the fault and its reason, it is necessary to understand the problems that occur according to situations and to be trained repeatedly by comparing the difference in the measured data. Check again the key points of the task we've worked on in this training.
체크해보세요.
In this training, we have learned the low pressure, which is how to diagnose the failure of air conditioning unit. Everybody, thank you for your hard works.